Okay, so does anyone in the room know what their men's shoe size is? Okay, so Jazzy, does your shoe that you're currently wearing have the tag that says the numbers that you can that are actually like legible, that aren't worn off? Okay, so we're going to use Jazzy as our example. Okay, so everyone in my first hour, their sizes were like worn off of their shoes. Okay, so say you want to buy shoes that are originating from a different country. When you look at your tag, it has all these different numbers. So the Euro size is what most of Europe, except for the UK, uses, gentlemen. Okay. So all the shoe sizes are different. So you're going to need to use different shoe sizes depending on the shoes that you buy. So say you buy a pair of Birkenstocks. Birkenstocks are not sold in US sizes. They're sold in Euro sizes. So you need to know what your Euro size is. Now, it's all fine and dandy if Birkenstocks gives you an equivalent. Like sometimes they'll give you the size chart and it'll say like all of this stuff, like what the US size would be, what the UK size would be, what the Euro size would be. But they're all going to be different. We have equations that we can use. This is like literally one of my favorite bell ringers because it's usually, it works out and then students are like, oh, that's pretty cool. So it does pertain to what we're doing today. But we have two different functions. We have a function I of x, which is 2x plus 24. We're going to use our US size, put that in to get our Euro size. So Italian is using that Euro. So say you want, again, a pair of Birkenstocks. Say that Alfredo wants a snazzy pair of Italian leather shoes. He's going to need to know his Euro size for that. Okay? All right. So Jazzy said that she is a size men 6.5. Ooh, you still can buy kid sizes then. That's nice. That's cheaper. If you are a size 7 or below in men's sizes, you can buy the kid version. So youth sizes are men's sizes. So just a little tidbit. Get the kid sizes if you're a 7 or below in men's shoe size, the kid sizes are cheaper. All right, so Jazzy has 6.5. All right. We're going to put that 6.5 into the Italian or Euro equation. So we've got 2 times her size, 6.5, plus 24. 2 times 6.5 is 13. 13 plus 24 is a 37. Does that match your shoe tag for Euro? Oh. So is it a 7? Maybe they don't do half sizes, so maybe they bump it up to a 7. Because if it was 7, then that would work out to 39. Okay, let's put it back into UK from the Euro and see if it works out. So now we're going to we have our B function, which converts from Italian into British. So we're going to have to use both because Jazzy says that her thing for Euro says 39. Okay, so it might be because it's a smaller because it's a half size because they may not, some places don't recognize half sizes. So they might have bumped it up to a 7. So, we'll see. We'll see how this turns out. If it doesn't turn out exact, we're going to bump it up to what a 7 would be and see if it converts into the UK size. All right, so we're going to take that 37 and put it into the 1/2 times 37 minus 13. Oh, this is going to be a point, so this isn't going to work. But a 39 would be a point as well. All right, so half of 37 is 18.5 minus 13 is going to give us a 5.5. Does yours say 5.5 for the UK? 6, because it's going to not have it as a half size. Okay, so US might be the only one that has half size. Oh, here I have a UK point and a Euro 0.5. Interesting. Interesting. All right. So usually this works, maybe because it's a smaller size or a half size is why it didn't work. I had somebody that was a size 8 in men's in my last class, and it worked out exactly. So it matched his for the one person that could read their tag, or maybe they couldn't read their tag. I can't remember, because we were having a hard time finding somebody that could actually read their tag. Okay, so hopefully you're going to get that size chart conversion, but if not, this should technically work. But again, if they don't have half sizes, then you would probably have to round up, because you would rather have a shoe size that's a little bit too big than a half a size too small. Okay, so I don't know this. I made this smaller. I was trying out things. Mr. Zabel was trying to show me some. I showed him some functionality to the board that he didn't know. He showed me some functionality. So today what we're doing is composing functions. So you guys have evaluated functions. You've done operations with functions. Today we're going to compose, which does entail you evaluating functions. So back with what we did on Monday of last week is going to be put into this section. And then the last thing that we're going to learn starting on Thursday and into next week is inverse functions. So the composing and the inverse are definitely the more challenging of the 4 topics, but it's just because you haven't seen this before. Okay, so I want to color code this because this looks like it's just a jumble of letters. Do you agree that it looks like a weird jumble of letters here? So what it is actually is the F of G of X. So the F of G of X. Do you see how we have this open circle? This is the biggest thing of what you need to pay attention to, because it resembles a multiplication sign, right? But a multiplication sign is a filled in circle, and it's a little bit smaller than this. So if you guys had on your PACT tomorrow, this, without us doing it in class, you probably would have just multiplied it, which is not going to be right. So when you take your checkpoint is only going to be over composing and inverse. So everything is just going to be composing then on your test that looks, or on your checkpoint that looks like this. When we get to your test, your directions are going to be very clarifying. Because in the part where you're going to be multiplying, it will say, do the given operation to get your answer to the function. Operations are adding, subtracting, multiplying, dividing. Then the directions on this part are going to say, compose these functions. So if you read the directions, they're generally clarifying. But again, this open circle is going to mean compose a function. So what is composing a function? We actually work right to left instead of left to right. Usually we read left to right, we work left to right. This, we're going to move right to left. So we want to first, in this situation, if f of x is a pizza and g of x is pineapple, if we're finding the f of g of x, we're taking that pineapple and we're composing it onto the pizza. So then we have pieces of pineapple on our pizza. I'm not a fan of Hawaiian pizza, but in Hawaii I did eat Hawaiian pizza, but I would never I've never ordered Hawaiian pizza otherwise. Now, if we were composing G of F of X, that means that we're going to start with pizza and put pizza onto pineapple. So we have a piece of pineapple with a bunch of little slices of pizza. So what we're doing in this situation is whatever's on the right, we're plugging that into the X on the other function. So we're going to either do that to get an expression or to get a number. So gentlemen, so just like in the operations, if they give us an X in the parentheses, then we're going to have an X in our answer. If they give us a number in the parentheses, we're going to have a number for an answer. So, okay, seriously? Gentlemen, are we having an issue here? All right. So we have to do the G of X first, and we're going to compose that onto F. So what that means is that we're taking this, shucks. We're taking the G of X function and we're putting that wherever there is an X in the F of X function. So this G of X function is becoming our X in the F. So we are going to substitute that in. So then that means that we have 2 times X plus 5. So we put that G function into the X part of the F function. Did I lose anyone on that first step? So now we just have to get rid of the parentheses and combine like terms if there are like terms to combine. So if we have a number outside a parenthesis, we distribute it in. 2 times x squared is 2x squared. 2 times negative 3, negative 6. And then we have the plus 5. This piece right here are the only like terms that we have. So that's the only thing that we can combine. So the 2x squared stays 2x squared. Negative 6 plus 5? Negative 1. And that's our answer. Again, if it feels a little uncomfortable, that's to be expected because you've never done this before. So now on our second example, we are going to find the G of f of x. So that means that our f of x function, that's going to be put into wherever there's an x on our G of x. So we have 2x plus 5, that's our x. X squared minus 3. So we took our f function and substituted that in for our x on our g function. Benji, is Miguel being mean, or are you just a little jumpy this morning? Zach, what does 5 squared mean? Huh? But what does it mean? How did you get 25? You're right, 5 squared is 25, but what does 5 squared mean? How did you get the 25? 5 times 5. You multiply it by itself, right? So squared means you multiply it by itself. So squared means you multiply it by itself. We did this when we were doing multiplying last week. We used the boxes, yes? Or if you use the rainbow method or foiling, any of those ways are appropriate ways to get the answer. I just prefer the boxes. Two times 2 is 4. X times x is x squared. 2 times 5 is 10, and there's still an x. 2 times 5 is 10, and there's still an x. And 5 times 5 is 25. I'm going to rewrite that 5 because it looks like an 8. 25. There, that's better. Okay, did I lose anyone with my box? Because Zach told me that when you have something squared, that it's multiplied by itself. So if I had 2x plus 5 squared, that means it's 2x plus 5 times 2x plus 5. So thumbs up, sideways down with where I got that box from. Sideways? Okay. Miguel. Zach told us that 5 squared means 5 times 5, right? So then, watch. So 2x plus 5 squared means 2x plus 5 times 2x plus 5. So I'm just trying to simplify this junk here in my box up there, okay? So I've got, there's only one x squared, so 4x squared. Then I combine 10x plus 10x, which is what? 20x plus 20x. Then I have the plus 25. That's from my 2x plus 5 squared. I still have this minus 3. I'm sorry to bore you. Those are the only two things we can combine. So our answer is 4x squared plus, squared plus 20x. What's 25 minus 3? 22. That's our answer. Again, this is new, so if it feels a little uncomfortable, it should. That's normal. Okay? So just like when we were evaluating functions, you can evaluate a function when you have equations, but you can also evaluate when you have graphs. So we can also compose functions when we have graphs. So we have h of x and k of x. We work from right to left. Again, since you've never seen anything like this before, it would probably be the right day to not be screwing around and actually paying attention to the lesson. Just a shot in the dark there. That would probably make a little bit more sense. If you've never seen it before, that you probably want to pay attention. Or not. Okay? So we want to look for the right. So we have the h of 1. That means we're going to use the blue graph. So the h of 1, what is the number in the parentheses going to signify? What is that going to represent, Alfredo? If it's in the parentheses, what is it standing for? If it's in the parentheses, what is it standing for? The x, okay? So we want to find where the x is 1 on this graph. X is 1 is along this line, this vertical line. So it hits at that point. What is my y value at that point? It is 1. So now that answer becomes the parenthesis for the k graph. So we're finding then the k of, okay, the k of 1. Because the h of 1, that answer was 1. So wherever there's h of 1, we're substituting a 1 in for that value. So now I've got to go to the k graph, the green graph. And I need to find where x equals 1, which is along this vertical line. Bam, that's the point. What is the y value at this point? -2. So the k of 1 is a -2, and that's my overall answer. Done. Again, if it didn't click right away, we have 3 examples, and this is something that's new. So it should not appear easy. We want to go from right to left. So in B, we're finding the k of -2. So we go to the green graph, find where x equals -2. X equals -2 right here. Where does that hit on the graph? Bam. It is at 1 because we're trying to find the y value. So now we're finding the h of 1. So we come over to the h graph. The h of 1, well, guess what? We just found that. We just found the h of 1 over in the last problem. The h of 1 is 1. That's our answer. For our last one, we're only using the h graph. We're not even using the k because it says the h of 2. Well, what the heck does that mean? That means that we're going to find the h of 2, and whatever that y value is, we're going to substitute that into our h graph again. So the h of 2 is right here. So my y value is 1. So now I need to find the h of 1. Oh, crud, Mrs. Payless, you guys didn't correct me. All right, do over. I was on the wrong graph. There we go. All right, so I'm a dork. The h of 2, here is where h of 2 is. Bam. Now, that is at a -1. Sheesh, Payless. H of a -1, I need to go where x is -1 now. It hits the graph here. What's my y? 5. Okay, let's start on these graphs, or these equations. We've got f, we've got g, we've got h, and k. So our first equation is finding the k of g of 0. Now, if you look on all of these problems, they're giving us a number in the parentheses. So they're going to be giving us the number that we plug in for x. So our answers are going to be numbers here. The last ones, we had x's. So our answers had x's in them. This one, because our x has a number, we're going to have a number answer. So we take the g of 0 is 3 times x, which they give us a 0, squared plus 2. What's 0 squared? 0 times 0 is 0. What's 3 times 0? 0. So the g of 0 equals 2. Now we put that 2 into the k function. So the k function is 5x, which that's the g of 0. So 5 squared, because our g of 0 ended up being a 2, plus 16. Zach, what's 5 squared? 25. And what's 25 plus 16? It is 41. And that's our answer for that problem. So we put in the x that they gave us, the number value for the x, into the g function, and then got that answer and put it into the k function. Let's try to do the g of h. G of h of 9/4. It looks crazy, but it's not. You can put it into your calculator. Okay? So let's find the h of 9/4. The h is going to be the cubed root. You can find that under the math button of 4 times 9/4 minus 1. You could just put that into the calculator. On your calculator, you're going to hit math, and you'll see that the cubed root is on option 4. So you're going to hit math 4, and it gives you the parenthesis, and you would put in 4 times 9/4 minus 1, and parentheses, and you should get 2. Why is that? 4 times 9/4 is 9. 9 minus 1 is 8. The cubed root of 8 is 2. Again, you have a calculator to calculate it for you. So now we're going to put that into our G. The G of 3x squared plus 2. Ah, shucks. All right, we will pick up where we left off on Wednesday.